Hi everyone, my name is Dan Blair and I work with the Chippewa Luce Mackinac Conservation District. There, my role is the watersheds coordinator. As the watersheds coordinator, I work with a variety of landowners and community members to implement different management practices that are all aimed at improving water quality. Management practices can vary drastically on what I do. For example, I can work to install buffer strips. I've worked to do stream bank restoration projects, and it can also be as simple as livestock exclusion fencing. Today, what I'd like to do is take water quality measurements in two different places in the Mackinac River watershed. The first location is here in an area that is relatively undisturbed and seen little development, and compare that to an area that has seen more urban development, more agricultural development, and see how different water quality parameters may differ. The four parameters I'm going to look at are first pH. pH is a measure of how acidic or how basic something is. And whenever we're looking at water quality, we want to look for a pH of around 7, which is neutral. The second parameter I'm going to look at is dissolved oxygen. Dissolved oxygen is a measure of the dissolved oxygen in the water. Um, Oxygen levels can vary from 0, which is no oxygen, to we can see levels as high as 18 milligrams per liter, which is high. Um, Typically, in most systems that support a healthy fish population and other aquatic organisms, we're going to see dissolved oxygen around like 6 and above. That's typically a good level for fish to grow, reproduce, and spawn, and along with other organisms to survive in that water body. The third parameter we're going to look at is specific conductivity. Specific conductivity is a measure of how of the water's ability to pass an electrical charge, and that is directly related to the ions in the water. Ions are typically in the form of salt, and we'll see like high specific conductivity readings in areas where there's a lot of like road salt runoff. In most systems, the range is about 150 to 1500. With we want to see levels around 300. That's 300 to 350 is a good level for aquatic organisms. And then the fourth parameter we're going to look at is temperature. Temperature we're going to take in degrees Celsius, and yeah, it's just the temperature of the water. And the temperature affects growth rate of organisms, and also can affect conductivity, affects dissolved oxygen levels, and affects all other parameters. So with that being said, the equipment we're going to use today is vernier equipment. We got a small unit, and with that unit we attach a probe with a sensor on it. This is the pH sensor, and the way this equipment works is there's a small little sensor at the end of each of these probes, and we're going to stick that into the water. The number is going to bounce around, but it's going to settle around the number, and that's the reading we're going to take. So let's do some readings. So here we are at site 2. This site, as you can see, is visually different. I can hear cars in the background. We pass quite a few agricultural fields, some residential and urban development on the way. This site, we will expect to see different readings because of that. We're also in a different soil group here. This is primarily clay soil, so the water is more turbid. There's less buffer along the river system, and there's just a lot more impact along the river itself. So we'll take some measurements here and then compare the results with the first location. Alright everybody, welcome back. I took the readings that we got from both Site 1 and Site 2 and put them into an Excel spreadsheet, and then put them onto a document so we can easily look at them and compare them. If we recall, Site 1, it was less developed, seemed kind of pristine in a way, lots of trees, lots of wildlife. That was actually a portion of the Rapson Creek. The Rapson Creek is in the southern part of the Mackinac River watershed, and we were actually up close towards the headwaters. Site 2, a little more muddy, as we can see. seemed to be a lot of debris in the water. There was development. We could hear cars in the background. That was a portion of the main branch of the Mackinac River. So if we look at the measurements we took and compare them, the first measurement we took was temperature. Um, at site 1 we got 19.2, and at site 2 we got 19.4. They're similar. Both areas we took, where we actually took the readings, it was kind of shaded. And both sections are cool water stretches of the Mackinac River watershed, so we'd expect to see similar temperatures. It is late August too, so consider that we would likely see high temperatures like in the 19-degree range. Portions of the watershed will actually see 20 to 22 plus degrees Celsius. So these measurements are kind of what we'd expect, and there's not a huge difference between them. The second measurement we took was dissolved oxygen. Site 1 we got 8.98 milligrams per liter, and then site 2 we got 7.7 milligrams per liter. The site 1, which is the Rapson, we saw higher dissolved oxygen. We'd expect that. Might have been hard to see in the video, but site 1 there was a lot of aquatic vegetation. There was potamogetons, pondweeds, there was elodea, which is water weeds, different species of emergent vegetation that was in the area. And typically in these streams and rivers, if we see a lot of vegetation like that, we'll see higher dissolved oxygen because plants photosynthesize and replenish dissolved oxygen in systems. Something else to note is site 2, there was a lot of runoff that was occurring, lots of debris in the water, muck, we can say. The more organic material in the system, typically we'll see lower DO, because when bacteria decompose that material, it uses up dissolved oxygen, and that will lower the DO in the system. One thing I want to touch on real quick is DO and temperature are inversely related, which means the higher the temperature, the less dissolved oxygen the water can hold, and then vice versa. That the lower the temperature, the more dissolved oxygen the system can hold. So looking at our third measurement, we got pH here. First site was 7.09, which is close to that neutral, which we want to see, and then at site 2 was 8.2. This might not look like a huge difference, but on a pH scale, change in a unit of 1 means change in 10. So what that means here is the pH at site 2 was 10 times more basic than site 1. This change likely has to do with non-point source pollution in the area being deposited into the river. It deposits different materials which will increase pH of the system. What those are exactly, we'd have to dive into that just a little bit more, but I'm trying to keep it short here for everyone. So looking at our next measurement is specific conductivity. If you recall, the magic number we look for is kind of around 350. We can just say between 3 and 400. We are a little bit higher than that here. That is because we are essentially in a clay basin in the Mackinac River watershed. Clay soils, you will see a higher conductivity. The reason for this is the presence of materials that ionize in it. When materials ionize, they become ions and they become charged, which in turn increases likelihood to pass electrical current, which in turn increases conductivity. Again, the cause for difference is probably runoff in the area. Both measurements are kind of close to each other. I mean, we're talking, just around 20 microsiemens per centimeter difference. So it's not a huge difference. If we came back in springtime during snowmelt and compared conductivity at the two locations, I'd expect to see a much more drastic difference. The reason for that is the use of roll salts in the area. In the spring, whenever all the snow melts and all that runoff occurs, the road salt that we use, on our county roads and whatnot, it it gets deposited right into these tributaries, and that would really increase connectivity, and that would definitely affect it in Site 2 more than Site 1. So um, I hope everybody learned something and enjoyed this short little video on water quality in the Muscogee River watershed. Thank you for tuning in, and have a nice day.